IGCSE Computer Science, Syllabus Statement 1.3.3a, describe the principles of operation of 2D scanners, and describe how they are applied to real-life scenarios. So, this is the first part of input devices. Now I decided to have one video equals one input device, because it's a little bit easier to find a specific input device that you want, and the videos are much shorter that way. However, there are going to be more videos, so keep that in mind. But they don't, like, if I split them up into these small parts, they don't take me that long to make. They only take me about 10 minutes to make. So, well, as opposed to an hour or two for a normal 10-minute video. Well, an hour plus a lot of breaks. But anyway, let's go ahead and get started with this. So there are quite a lot of devices that we have to cover in this topic, but hopefully we'll get through, I guess. Alright, so yeah, a 2D scanner is, I'm pretty sure everyone knows what it is or has heard of one or used one, and it's pretty much something that can scan or input like a physical object, usually paper documents, and storing them in a computer in an electronic form, such as a PDF or a JPEG. A scanner kind of looks like this. So, an example of the use of a scanner we're going to get to later, but like scanning passports at airports, and we're going to be discussing that towards the end of the video, when they apply to real-life scenarios. So here's how a scanner works. The document is placed on the glass panel of the scanner. A bright light is emitted, illuminating the document, usually from a xenon lamp. A scan head is moved across from under the panel, scanning the document. Now you can kind of see that if you ever scan a document without the lid covering it, you can kind of see this light move across the panel. That's pretty much the scan head, which is moved across. And an image of the scan is produced and sent to a lens using mirrors, and the lens focuses on the document image. The focused image falls onto a CCD consisting of integrated circuits etched into silicon. The CCD is made up of thousands of light-sensitive elements, which produce electrical charges when light falls on them. The scanned image is now turned into an electronic form, which software can produce an image from. So, for example, if you scan a document such as a textbook cover, for example, I don't know what I thought of that from, then you can get an electronic copy on your computer of that image. Now, computers with OCR software allow scanned text to be converted into a text file format. So basically, if it's, say, a page from a book that you scan, then OCR can look for these letters in the scan of the file, and then you can use it to, like, for example, change or copy text. It's quite useful. So the scanned image now can be changed by importing it into a word processor. If the document is an image file is formed, such as a JPEG file. So here, let's look at the uses of 2D scanners. So as said, they can be used in airports to read people's passports. And OCR software can be used to change or copy text in electronic form of the scanned passport. And the photo in the passport is also scanned and is stored as a JPEG file, although not necessarily only a JPEG file. Just an example. Photo of the passenger's face is also taken at the airport, and it's compared with the image in the passport. So this is how it works. When the two images are compared, software will check the distance between the eyes in both images, the nose width, the shape of the cheekbones, the length of the jawline, and the shape of the eyebrows. So this is all for security, pretty much, in an airport. if they want to check that you are the same person from the passport that you're using, just to make sure that it is actually you and that you're not stealing somebody's passport, then they will do that just for security. Hi GCSE Computer Science. This is syllabus statement 1.3.3b. Well, actually, it's the same syllabus statement, but again, I'm going to be having different input devices for each video. But otherwise, it's the same statement pretty much, but yeah. Anyway, 3D scanners. Now, we looked at 2D scanners in the last video. 3D scanners, of course, work a bit differently, because in 2D scanners we have X and Y coordinates. In 3D scanners we have X, Y, Z. So we're going to see how these work. So, of course, a 3D scanner scans a solid object and produces a 3D electronic image of it. So this is what one looks like. You might recognize this. I googled this and I found it. Thought it looks quite cool. So 3D scanners take a number of images to produce a digital 3D image. And the scanned images can be used in CAD. So like, what we're going to look at also is 3D printers. And we can see how what you could do is use a 3D scanner to scan an object, such as a TV remote. And then you could use a 3D printer to print that object using computer-aided design. 3D scanners use tomography, which means an object is scanned by the scanner taking multiple pictures, which are slices of the object from different angles, and pieces the slices together to form the 3D object. And this is done by using X-rays, radio waves, gamma rays, or other methods. So we'll look at 3 of these. So we'll look at the array and the type of scanner. So like X-rays, CT scanners use X-rays. MRI scanners use radio waves. And SPECT scanners use gamma rays. So these are just examples of what types of scanners use for their rays, for taking pictures of the object. So this is what it kind of looks like. So as said earlier, slices are taken and then the image is formed. So I thought this was a pretty good picture showing how these slices work. So we get like these slices, really thin slices, stored on a computer, and then they're pieced together to form 3D images. Hi GCSE Computer Science, syllabus statement 1.3.3c, and this statement we're going to be looking at barcode scanners. Now we looked at 2D and 3D. Well, barcode is quite a bit different from those two, and I'm pretty sure everyone here knows what a barcode scanner looks like, what a barcode looks like. But if you don't know, a barcode is a series of black and white parallel lines of different thicknesses. So look kind of like this. You may see these in supermarkets and libraries. So this thing scans this thing. So the numbers on a barcode 0 to 9 are represented by series and thicknesses of the black lines. Barcodes usually have a left-hand side and right-hand side separated by things called guard bars. So if you take a look at this again, guard bars are here, they're here, here, and here. You can see these two parallel lines here. The guard bars. Each digit in a barcode is made up of 2 black lines and 2 white lines of different thicknesses. The width of each digit is the same, so the speed of scanning will always be the same. So it tends to be pretty quick. Like, the only problem is with some supermarkets that I go to, like it takes a while for them to focus on the barcode, or they can't find it, or like there's some error, so they have to type it in on the keyboard. It's kind of annoying, but otherwise the scanning speed is pretty much the same. It's pretty quick. The digits on the left-hand side start with a white bar, and the digits on the right-hand side start with a black bar, usually, which allows the I think it's usually, I'm not sure, which allows the barcode to be scanned in any direction. So, yeah, even if your item is upside down, it doesn't really matter. So the barcode is read by a red laser, or an LED, and when this happens, the white bars reflect most of the light, while the black bars absorb most of the light, allowing the barcode to be read. So if you know anything about physics, you'll know why this is the case. Now, this reflected light is read by photoelectric cells, and a pattern is generated, and this pattern is converted to digital data. So, for example, if a barcode digit is represented as black, white, black, black, white, black, white, black, that is like the number of consecutive black or white means thickness. So like one line of black, one line of white, two lines of black, one line of, if you get the idea. It'll look like that physically, but it may, like the computer will read it as binary, of course. So 10110101, assuming that black is 1 and white is 0. And as you know, barcode scanners are usually found in supermarkets. So this is pretty much what happens. So the barcode is scanned and the barcode number is looked up in the supermarket's stock database. So when this number is found, the stock item record is looked up. And the stock item record has details of the item, such as the price and description or some other stuff, as well as the amount. And these are returned to the checkout, or POS, or point of sale terminal. The number of stock items is reduced by 1 in the record, and the new value is written. The number of stock items is then compared to the reorder level, which is basically a set number, which will decide whether a reorder is required or not. And if this value is less than or equal to the reorder value, more stock items are reordered. And if an order for more items is generated, a flag is added to the record to stop reordering. So basically, say the reorder level was 50, for example, and you had 51 items. Someone bought one and it decreased to 50, then it automatically will reorder. It'll automatically send the reorder signal. But then after that, it'll say, okay, we got the signal, so if another item is reduced, don't send us another signal because we already have a reorder signal. Otherwise, if someone, say, buys 10 items after the number gets to 50, then they're going to have 10 reorders, and that might be quite annoying. And when new stock items arrive, the stock levels are, of course, updated in the database, obviously. So let's look at the advantages and disadvantages of the advantages of barcodes to management and advantages of barcodes to customers. There are a few disadvantages, such as, well, as I stated earlier, maybe could be reading errors of some sort. But we'll mainly look at the advantages because there are quite a few. So it's easier and faster to change prices of items. Checkout queues are faster. Maybe I should have had it this column and then this column, but whatever. Better up-to-date sales information. Reduction of errors. It's not necessary to write a price on every item in the store. Now that's pretty important because you don't want to have a job where you basically write the prices down on like one of those what do you call it? Some of those stickers where you can write on them. Can't remember the name. Is there a name for it? And then like put it on every item. Like you know, that's so pointless. Itemized bills can be printed, which basically means that you can have a receipt or bill with all of the items that you bought and their prices. Whereas if you didn't have barcodes and people had to write the total price down using a calculator, then just makes it a bit easier. It also allows automatic stock control, as seen earlier. Cost savings can be passed on. Customer spending habits can be checked if barcodes are linked to customer loyalty cards. So you'd see what each customer likes, and then yeah, and of course better track of expiry dates. Now it's here because you don't want expired food. The customer would not like that. So yeah, that's pretty much it. Hi GCSE Computer Science. This is syllabus statement 1.3.3D, and we are looking at QR code scan. There are quite a lot of scanners in this topic, aren't there? The next video should be not scanners. It's going to be digital cameras, actually, followed by keyboards, mice, microphones, touch screens, a few other things, and then we move on to output devices. Alright, so QR code scanners are pretty similar to what we looked at last time, barcode scanners. It stands for quick response, and a quick response code is made of a matrix of black squares on a white background, something like this. Now if you go ahead and if you can find an app or software that can scan this, you can scan it. It'll take you to a link. I'm not going to tell you what link it'll take you to. You're just going to have to find out yourself. So normal barcodes can hold up to 30 digits, but QR codes can hold up to 7,000 digits, giving a greater scope of storage. And QR codes can easily be scanned using an app on your smartphone or tablet, and sometimes companies advertise their content by displaying barcodes in public for people to scan. Now, this is, of course, another advantage, as you don't need a barcode scanner. You don't have to carry a barcode scanner around with you to scan stuff in public and get to websites and stuff, but your phone can do it. Now, this is, of course, quite a big advantage, because most people carry phones with them in public. So, as said, an advantage of QR code is, it's not necessary for the user to type a URL, as they only need to scan a QR code with an app, and they will be directed to the website. And secondly, QR codes can be displayed pretty much anywhere in public, really, that's suitable, like trains, buses, magazines, business cards, and this gives an effective way of advertising. GCSE Computer Science, syllabus statement 1.3.3e, described the principles of operation of digital cameras and described how they are applied to real-life scenarios. So sorry about the huge gap between now and last week, because I didn't get much uploaded. It's because I had some exams which I had to get through, so yeah, let's get back on track. So digital cameras are pretty easy, because most people have them. And if you don't know what it is, a digital camera is a camera which can produce digital images that can be stored in a computer. So it could look something like this, but also if you have a phone or tablet or computer, those are examples of digital cameras as well. Because back in the day, cameras used film to record photos. So the photographer wasn't able to see what they have taken a picture of before it was developed. And this made their use quite expensive, as unwanted photos couldn't be deleted. So like, if you took an embarrassing picture of yourself in the shower, you just wasted some film. But nowadays, digital cameras have taken over. People can not only delete their photos now, but they can also transfer their photos to their devices using a USB cable or Bluetooth. So a digital camera is controlled by a microprocessor, which can automatically focus on images, automatically operate the flash, adjust the shutter speed, adjust the aperture size, adjust the size of the image, and remove red eye. So you may notice these features on your phone. It's like digital cameras can do these things, which can pretty much, well, I mean, really help, because, back in the day, you couldn't really remove red eye that easily. So a photograph is captured when light passes through the lens onto a light-sensitive cell. This cell is made of pixels. The number of pixels determines the file size used to store the image. Did we actually go through files? Yeah, I think we did. Back when we were looking at the third subtopic of topic 1. But by reducing the resolution, the storage requirement is reduced. The quality of the photograph depends on factors such as lighting and the type of lens used. IGCSE Computer Science, Syllabus Statement 1.3.3f, describe the principles of operation of keyboards and describe how they are applied to real-life scenarios. Now, this is going to be quite a short video, because, well, I only have one slide besides this. So, like, I usually have an image here for the each input device video and a short description on the top. But other than that, just one slide. So yeah. So, a keyboard is, well, we all must know what a keyboard is, because there might be one right in front of you. If you're watching this on a phone, you still have a keyboard on your phone, a non-screen keyboard. So a keyboard is connected to a computer using a USB or wirelessly with Bluetooth. And as said, phones and tablets use on-screen keyboards. Now laptops have a built-in keyboard. So not USB or wireless, it's, built in. Each character on the keyboard has an ASCII value. Each key pressed is converted into a digital signal, which the computer interprets. So we looked at ASCII in another video, the hexadecimal video. So it's pretty much like that. Whenever you type a key in the keyboard, the signal, that number, the ASCII value is sent to the computer, and it's interpreted. But keyboards are quite slow at inputting data. Most people don't really think so, but I mean, think about it. It took me like 10 minutes to make this entire thing. But probably the easiest way to input. Although we're going to look at microphones and how you can speak and input text, but even that is a little bit slow, because we'll look at that in that video. And also, using keyboards frequently can cause RSI. But this problem can be solved using ergonomic keyboards, where the keys are in a little different format and hand and wrist support is offered. So an ergonomic keyboard kind of looks like this. So as you can see, the keys are placed a bit differently, and there's a little bit of support at the bottom here. So that's pretty much it. IGCSE Computer Science, Syllabus Statement 1.3.3g, describe the principles of operation of pointing devices and yada yada yada. Anyway, a pointing device is a device used to control the movement of a cursor on a computer screen, like I'm doing now. So the pointing device I'm using is a touchpad. So some other pointing devices include like mice and tracker balls. Now, we don't usually use tracker balls, but we'll talk about how they are still used for some applications. So on a computer, selection of an icon or button is required. This can be done by using a mouse, tracker ball, touchpad, or even a touch screen. But the mouse is usually the most common pointing device. So some common mice forms include the mechanical ball arrangement, red LED used to detect movement, and wireless. Mice require space to move. Some mice need mouse pads, as some surfaces may not be able to support mouse use. Most mice have left-click and right-click buttons for selection and other functions. Some also have a scroll wheel, which allows rapid movement up and down a screen. So you usually get these features on a mouse. They're also like Razer mouse, like Razer mice. I was going to say Razer mouses. Ooh. Yeah, there are some Razer mice, like the company Razer, which can have quite a lot of buttons, and it's yeah, it's quite weird. It's usually like gaming mice. So that's because these other buttons can perform different functions, obviously. Tracker balls are usually used in industrial environment. Tracker balls also don't require much space to move, as the cursor is moved with a ball. Because of this, it is less likely to suffer from RSI when you're using them. It's like mice, you're always moving your hand around, but with tracker balls, you're just moving a ball. You can try to think of some ways tracker balls are used in industrial environment, like, I can't think of one off the top of my head, like perhaps in, I don't know, designing, like you might want to like use a tracker ball to move some stuff. Never mind, I can't really describe it, but like mice, tracker balls may have buttons for selection and other functions. Most laptops have touchpads. A touchpad is a tactile sensor which is used by moving fingers over the pad to move the cursor, like I'm doing now. Touchpads may also come with a left click and a right click, with left click and right click buttons like mice do, but for some trackpads, selections can be made by tapping the surface, like my touchpad can be made by tapping it. IGCSE Computer Science, Syllabus Statement 1.3.3H. Describe the principles of operation of microphones and describe how they are applied to real-life scenarios. So, a microphone is a device which can input sound into another device. I'm using one right now, and I'm pretty sure most people have used them as well. So, like when chatting with their friends on on their phones and going on Skype and whatever, microphones are used for that. So, microphone kind of looks like this, but it can also be like holes on a computer. Yeah. So microphones can be used for doing a voiceover in a presentation, speech recognition, voice recognition, and enabling disabled people to communicate with their computers. But the two major uses that we're going to look at are speech recognition and voice recognition. Now, voice recognition is a little bit simpler, so we'll start with that. But before that, we should look at the principles of operation of microphones. So when a microphone detects sounds, a diaphragm vibrates, producing an electrical signal. This signal is transmitted to a sound card and is converted into digital data and is then stored in the computer. Simple. Now, voice recognition. What happens is the user's voice is detected and then converted into a digital wave pattern. Now, as we'll see soon, when we're looking at sensors, we'll see that we know that computers can't actually read like physical data. It's going to have to be converted in some way. So we'll cover all that in sensors. So once you watch that video, it'll make more sense. But for now, let's just stick with this stuff. So software will then compare this wave pattern with stored wave patterns to see if they match. If they match, the person has correctly been identified. Yay. Only certain words can be used in this, usually, as most systems are limited to only recognize keywords or phrases. This technology is good for security. Now, what we mean by it's good for security is, well, actually it's pretty obvious, but like say you want to protect a room which had secret files, so only you were allowed in there. What you could do is set up voice recognition software which will allow access if it senses your voice. If it's not your voice, then they won't allow access. That's pretty much how it works. Speech recognition is a little bit different though. In speech recognition, software tries to recognize the words spoken by the user as opposed to the user's voice. The spoken words or phrases can be displayed, input into a word processor, or used in other application. So this is how it works. When a sound is inputted, the sound card in the device will convert the sound into digital data. The software will take the digital data and break it up into phonemes. Now, what a phoneme is it's how do I explain this? It's kind of like the sounds in words, like the individual elements of the sounds in words. So like hello would be ha, o, u. So those would be the phonemes, the individual sounds in. Anyway, these phonemes will be compared with words in the built-in dictionary, if there is one. The word spoken will then be suggested by the software in the application being run, and hopefully it's reliable and will output whatever has been spoken. The concept of speech recognition is far more complex than that example. Now, we looked at keyboards in the other video, and I talked about how keyboards, like maybe I've got a jar of nuts here. Anyway, keyboards like they're quite slow at inputting data, but it may be the easiest. Now, this is why. Speech recognition can be quite hard to use. Like, you could say something and the computer could misinterpret it totally. If you've ever spoken to Siri or Cortana, like, you may notice that some words that you say may not be recognized or like misinterpreted. So like, well, we'll look at an example now. The reason for this is the software must take into account different dialects and accents when trying to recognize what has been spoken. Now, this is pretty important because people around the world have different accents. It's like the Indian accent, the Russian accent, the I don't know, the Asian accent. Yeah. Anyway, so yeah, it's pretty it's pretty complex for the software having to take into account all of this. So let's look at an example. So the phrases recognize speech and wreck a nice beach sound similar, kinda. But if the software breaks these up into phonemes, they will be very similar. So wreck a nice beach something, and blah blah. So speech recognition can be used in cars. Commands such as turn on GPS and windows down will turn on the GPS and roll the windows down. So hopefully you have an understanding of how microphones work and two of its major uses. And hopefully this will be on the exam because I wouldn't want to waste my time doing this. But yeah, thanks for watching, and as always, see you guys when I see you guys, and yep. GCSE Computer Science Syllabus Statement 1.3.3i. Describe the principles of operation of touchscreens and describe how they are applied to real-life scenarios. So, touchscreens are basically devices which allow the user to interact by touching areas on a screen. So, most of your phones may be touchscreen. So that's an example of a touchscreen device. So I have some pictures here. So we're going to be looking at three different touchscreen technologies: capacitive, infrared, and resistive. And there are benefits and drawbacks to each of them. So yeah, we'll be looking at principles of operation of each system, the benefits and the drawbacks. So let's get started. So just a little introduction. Touchscreens are very common, and they're simple to use as they only require the user to touch the screen, which everyone can do because we use our hands in everyday life. So, you know. And as said, there are three major types of touchscreen. The first one is capacitive. So we have a description, advantages, and disadvantages. So capacitive touchscreen device is made up of multiple layers of glass, which act like a capacitor, creating electric fields between them. The electric current changes when the glass is touched, and the coordinates where it was touched is determined by a microprocessor. So, examples of capacitive devices include like Apple iPhones and Samsung Galaxies. The advantages of capacitive devices is medium cost, good screen visibility in sunlight. There's multi-touch feature. You may notice that some of your smartphones you can multi-touch. And the screen is quite durable. Quite a large impact to break, but don't try it because I have friends who have broken screens. The only real disadvantage of capacitive is allows only the use of bare fingers and sometimes a stylus for input. Now, this might be considered an advantage actually because, well, you know, what else are you going to touch the screen with? Yeah, it's not like you're... And also, if it allows fingers only, then you can keep it in your pocket without having to worry about, you know, your pants having to touch the screen, which is quite annoying. But yeah, it's considered a disadvantage because you might want to touch the screen with some other stuff if need be. So a capacitive touchscreen device kind of works like this, kind of looks like this rather. So there's the microprocessor, there's the screen, and electrostatic field caused by touching the screen, and coordinates are fed back. It's kind of like this. So there are two different types of infrared technology. There's heat sensitive and optical. So we'll look at both of these here. So both systems, both heat and optical, use glass as the screen. Heat sensitive uses a warm object as input, and the optical system uses an array of sensors, kind of like an invisible grid, and the point of contact is determined based on the grid coordinate touched. So examples of infrared devices include the Samsung U600 and the Samsung SGH-E900. Yeah, I did some research. Yeah. Advantages are multi-touch capability is permitted on both systems. The screen is quite durable, and the optical infrared system allows the use of bare fingers, gloved fingers, or stylus for input. I guess it's one of the disadvantages of capacitive is if you have gloves on, you can't really use the phone. But infrared is quite expensive, and they only have fair screen visibility in strong sunlight, so it's kind of annoying how, yeah. And the heat-sensitive system allows only the use of bare fingers. Now, there's also one other thing. With the heat-sensitive system, if you're using a heat-sensitive device in cold weather, your fingers are cold, then it's not going to work if you try to touch your screen. So that's why heat-sensitive systems aren't really common. So the optical system kind of looks like this, if you were wondering. So the grids here, and yeah. Our final system or technology is resistive. So resistive phones have an upper layer made of polyester and a bottom layer made of glass. When the top layer is touched, it completes a circuit with the bottom layer. The signals are then sent to the microprocessor, which calculates the coordinates where the screen was touched. Now, examples of resistive phones are the LG Optimus and the Nokia N900. Again, research those. Advantages of resistive include it's quite inexpensive, allows the use of bare fingers, gloved fingers, or stylus for input. And of course the disadvantages, there are always disadvantages. Poor screen visibility in strong sunlight, there is no multi-touch capability, and there's only fair screen durability, so the screen tends to be vulnerable to scratches and can wear out after some time. So if you're wondering what it kind of looks like, here's the top layer, here's the bottom layer, and when touched it completes a circuit, and the microprocessor or controller determines the coordinates from that. Hi GCSE Computer Science, Syllabus Statement 1.3.3J, and this is about interactive whiteboards. Now this is the last of the input devices that we have to cover besides sensors, but sensors is kind of a whole different thing by itself. Anyway, an interactive whiteboard is a device which can display computer images on a whiteboard using a projector. Now your school may have interactive whiteboards, such as the smartboard here. So we're going to be describing how they are used and how the advantages. So they allow the user to write or draw on it, but unlike a regular whiteboard, these writings or drawings can then be stored in electronic form on the computer to be used for later. And this is handy because if you use a regular whiteboard, you draw stuff, you might have to save it, you might have to take a picture and then store it on your computer, but with an interactive whiteboard you can just save it on your computer. It's quite handy. And this can be helpful in meetings or classes in school. For example, a plant cell is displayed on the whiteboard in a biology lesson. It's possible for students to label the parts of the cell on the whiteboard and have the annotations saved on the computer for the next lesson. So here we've got a plant cell. I sort of drew this, kind of looks really weird. So we have the cytoplasm, the cell wall, the vacuole, cell membrane, chloroplasts, and nucleus, and you can annotate this, and this whole thing can be saved for later use on the computer, so that in the next lesson when we come back to learning about plant cells, then we don't have to rewrite this. We can save whatever's been done here. So it's pretty much how an interactive whiteboard works. It's also possible to interact with the interactive whiteboards using our fingers on the surface. And doing this, people can do on the whiteboards what they can do on the computer, such as browsing the internet or playing a game. And since a whiteboard is being used and it's quite big, many people can watch and get involved. And this is it's another advantage of them. GCSE Computer Science, Syllabus Statement 1.3.3K. Describe how a range of sensors can be used to input data in a computer system. So, sensors are a type of input device, but they're a little bit different. What we need to know for the course is a bit different. We need to know more about sensors than any other input device. I think, because the input devices that we learned previously, such as the touch screens and the whiteboards and all that good stuff. We just have to know the theory, the principles of operation of them. But here with sensors, we have to apply them into scenarios which we don't know basically we don't know what we're going to get in the exam. They're going to give us a scenario. We have to describe how sensors can be used for that. Now that'll be looked at in the next video, but this video will go through all of the 9 sensors that we need to know, and then we can learn about how they are used, and we'll also go through an exam question as well in the next video. So sensors are devices which read or measure physical properties. So these basically are sensors. These are the 9 sensors that we have to know. This is the temperature sensor. This is the moisture or humidity sensor. This is the light sensor. This is the infrared or motion sensor. This is the pressure sensor. This is the sound sensor. This is the gas sensor. This is the pH sensor. And this is the magnetic field sensor. So these are what we have to know. So we'll look into them now. So basically, physical data is what is known as analog. This means that it's constantly changing and doesn't have a discrete value. Analog data requires some way to interpret. For example, a mercury thermometer requires you to look at the height of the mercury. So temperature can therefore have an infinite number of values. As humans, we can read these values. Like, we can look at a clock and say, oh hey, it's 12 o'clock. Or we can look at a thermometer and say, oh, it's 35 degrees. But computers can't simply look at a device and say, oh, it's 12 o'clock. Like, the data needs to be in some sort of digital format, like a format that the computer can understand. This is done by using an analog to digital converter, or ADC, as we're going to call it for now. This device converts physical analog values into discrete digital values. So we get the analog data here, the ADC, and the digital data. Now, we don't have to know how the ADC works. We just have to know that it plays a part in changing analog data into digital data. When computers or microprocessors are used to control devices, it is necessary to use a digital to analog converter, so a DAC. And these are used with an actuator, which is a type of electromechanical output device used to control something. So an actuator could be like a relay or motor or valve, and we'll learn about these in output devices, because an actuator is an output device. But just know that actuators are used in the process of a sensor system, really. Actuators may require a digital to analog converter to receive an electric current rather than a digital signal. So we need to think about when microprocessors can read digital values, actuators have to read analog values. So we have to convert digital values into analog values. Something like this. So let's look at the sensors and the application of the sensor. So temperature we'll start with. So temperature can be used to control a central heating system, and controlling and monitoring a chemical process, and controlling and monitoring the temperature in a greenhouse. Now, note the difference between controlling and monitoring. Now, controlling is when you control something. So the microprocessor has something to do with the control of devices, of actuators. Monitoring is a bit different. Monitoring is when the microprocessor can read values but cannot do anything about, can't change anything. All it can do is monitor, and if something is out of place, it can output a warning message. So we'll look at that in the next video as well. Moisture/humidity, used for controlling or monitoring the moisture levels of the soil in a greenhouse, controlling or monitoring the humidity levels of the air in a greenhouse, monitoring the dampness in an industrial application. Light sensors can be used to control street lights, controlling and monitoring lights in a greenhouse, and controlling headlights in a car. It's important that you know about these applications, just in case the exam throws something at you. So, for example, if the exam says, oh hey, describe how a microprocessor and a humidity sensor can be used to, control the humidity levels of the air in the greenhouse, then you're going to have to know these applications so that, you can just know what to do for the exam. Infrared or motion sensor, controlling the windscreen wipers in a car, monitoring intruders in a burglar alarm system, and controlling doors in a shopping mall. So like when you walk into a shopping mall, ooh, the door's open. That's done by a motion sensor. Pressure sensor, monitoring intruders in a burglar alarm system, controlling a weighing system, and controlling and monitoring a gas pressure related process. Also, pressure sensors can be used to control doors in a shopping mall as well, as they'll sense your weight and then open the door. Sound sensors can, again, monitor intruders in a burglar alarm system and monitor the noise of liquid dripping from a pipe. And finally, last slide, gas sensor can monitor pollution in water or in the air, monitor the oxygen and carbon dioxide in a greenhouse, and monitor carbon dioxide leaks in a power station. pH sensors, controlling, monitoring the acidity or alkalinity of soil in a greenhouse, and monitoring pollution in water. And magnetic field, last one, controlling an application which involves magnetic field changes, and controlling an anti-lock braking system in cars. An application which involves magnetic field changes, well, that can include stuff like cell phones, or, yeah, so it's like, take your mobile phone, for example, or like tablets. Like, you could have orientation. If you turn your phone around, the screen will also turn. So that's pretty much how these can be used. G50 Computer Science, Syllabus Statement 1.3.3L, describe how sensors are used in real-life scenarios. So, the last video that we looked at was the sensors themselves. Now, you're going to have to watch that video before watching this one, because you're going to need to know about all the sensors before you go ahead and start using them. So, go ahead and do that, and once you're done with that, come back and we can get started. So, I said in the last video, I said something like, we need to be able to use sensors in the exam. They might ask us questions. They might give us a scenario where we have to describe how sensors and a microprocessor are used. Now, this isn't like the other input devices that we learned. We looked at like digital cameras and keyboards and mice and stuff like that, and it was all theory that we had to just understand, memorize, pretty much. This is a bit different. This is where we have to learn about the sensors and know how to apply them in scenarios that the exam gives you. Now, we don't know what the exam is going to give us. It's going to give us something like, a greenhouse has a carbon dioxide supply and something like that. Describe how a microprocessor and a gas sensor could be used to control it. So we don't know what we're going to get. So we need to be able to look at scenarios where, we have to get into practicing how we can use microprocessors and sensors to control a system. So that's pretty much what we're going to do in this video. We're also going to do we're going to do 2 examples and an exam question. So let's get to it. So this is the process of the basic process of sensors in a microprocessor. So sensors send signals to a microprocessor or computer. Signals are converted into digital, if required, using an ADC. The microprocessor or computer checks the data received against stored values, and if the data received is outside a set range, that is the stored values, then, well, 2 things can happen. Now, it depends on what application is being used, or what system is being used. If it's a monitoring system, then a warning message or alarm is output. If it's a controlling system, then the computer or microprocessor will send signals to control actuators to deal with that problem. And of course, the signals might have to be put through a digital to analog converter, or DAC, in order for that to happen. So we'll look at a monitoring example and a controlling example in this video. Then we'll look at an exam question. There are sirens outside my house. Great. So let's look at a burglar alarm system, because I mentioned that with quite a few sensors in the last video. So here's how we could do it. So an infrared sensor senses movement of an intruder, or a sound sensor senses footsteps or breaking glass, or a pressure sensor senses the weight of an intruder, or all 3. If you really want to... Anyway, this data is put through an analog to digital converter. Then this data is sent to the computer or microprocessor for it to interpret. The data is compared with stored values. If the data is out of range, the computer or microprocessor sends signals through a DAC, if necessary, to sound an alarm. Well, yeah, it's probably necessary to sound an alarm or flash lights, or both. So that's pretty much how we have to structure our answers for a question that they give us in an exam. Like, I think that you get 1 mark for stating ADC or DAC. You get 1 mark for including the sensors, the microprocessor. So that's 3 marks. Comparing is another mark. And yeah, they're... Now the thing is, if they say a question is 5 marks in the exam, just know that they don't have an exact 5 points that you must include. It's quite open. Like, they'll have, say, 10 or 11 available marks for you, which you can include, and that'll be, well, yeah, basically there are a lot of marks available, even though it says it's worth 5 marks. You can still say a range of stuff, and you can get full marks, if you get what I mean. I'm not really explaining it clearly, I don't think, but anyway, you get the point. Now, a street lighting system, for example, is a controlling system. So we'll see how that works. So a light sensor on a lamp sends data to a microprocessor through an ADC. The microprocessor checks this data against the stored value. So stored value could be something, I don't know, light units or whatever. Now, if the data is less than the stored value, then a signal is sent to the lamp through a DAC to turn it on. Turn the lamp on, that is. If the data is higher than or equal to the stored value, a signal is sent to the lamp through a DAC to turn it off. Now, there's one question in the 2015 paper which said, describe how how the system will deal with brief changes in the light, so like heavy cloud covers, that are really brief, or like rain or whatever. Well, this is what you could say. Number of minutes pass before another reading. So you could say 30 minutes pass, 10 minutes pass. And now what this does is basically, if there's a brief like cover of clouds and the microprocessor senses this change, so the lamp will have to turn on, then, well, if then the cloud starts to, I don't know, disappear or something, and then reappear and disappear, reappear, or something like that. The lights, if it's constant checking, that is, then the light's just going to keep turning off, on, off, on, off, on, and that can be really annoying. So what the system can do is wait a few minutes before taking another reading, so that the light stays on or off, and then can continue. And this is, of course, a cycle, because it'll keep happening. So here's an exam question. The conditions in a fish tank are being controlled using sensors and a microprocessor. To keep the fish healthy, the temperature must be at 25 degrees Celsius, and the oxygen content needs to be 20 parts per million. The tank contains a heater and an oxygen inlet controlled by a valve. A valve, of course, is the actuator. So this is what you could say. Now, there are actually 2 questions to where I found this. There's question A, name the 2 sensors used. Now, we could see here, sensor A and B. Well, we've got a heater and an oxygen supply, so obviously sensor A will be a temperature sensor, and sensor B will be an oxygen sensor. So, yeah. Now, I think that can give you a mark if you say gas sensor. I don't think that matters, but, you know, still sort of gas oxygen thingy sensor. Then there's question B, describe how the sensors and the microprocessor are used to maintain the correct conditions in the fish tank. So here's how we could set out our answer. The temperature sensor and the O2 I should have subscripted that. Forgot to. It looks weird. So they send data to the microprocessor through an ADC. The microprocessor checks the received data against stored values, 25 degrees and 20 ppm, every 30 seconds. And if any of the 2 received values are out of their respective ranges, the microprocessor will send a signal to the heater or oxygen supply through a DAC to correct the error. Now, that should pretty much be, if it's a 5-mark question, then that should pretty much be the 5 marks, I think. If it's a bit less, then you can give an example, such as, you could say after this, for example, if the temperature is 26 degrees, the microprocessor will send a signal through the DAC to the heater, and we'll tell it to turn off for a while. Wait another 30 seconds, and then if the temperature is, say, 23 degrees, then the microprocessor will send a signal to the heater to turn on, and yeah, pretty much that.